Proving logarithmic properties. Number one, let's prove the product rule. So if we have log base b and we have the product factors x and y, then it's equal to the sum of the log of its factors. Now, the first thing we do is to let our right hand side, each term of right hand side, into, say, z sub 1 equal to log base b of x, and let z sub 2 into log base b of y. Next, we apply the definition of the logarithm with its corresponding exponential equation. So this one, so let's express this into exponential equation. So that is b to the z sub 1 equals x, and then this one is b to this z sub 2 equals y, and then let's multiply x and y together. So that's x is equal to b to the z sub 1, and y is equal to b to the z sub 2. Now we can, since they have the same base, we can multiply their exponents. So this is now xy plus b to the z sub 1. I mean, we can add their exponents plus z sub 2. Now this time we can apply again the definition of the logarithm of this one, corresponding to this exponential equation. So we have now log base b of xy is equal to z1 plus z2. Now let's write it here. Log base b of xy is equal to, or z1 is equal to log base b of x, and our z2 is equal to this from the start. That's log base b of y. And hence we have proven that the log of the product of x and y is equal to the sum of its factors. Number two, let's prove the quotient rule. So if we have log base b and we have the quotient xy, then that's equal to the difference of log of each factors, like this. So again, let's use this assumption here from the top. Let's x equals to b to the z1 and y equals to b to the z2. So let's start from writing x over y. Now, based from our assumption here, our x is equal to b to the z1 and our y is equal to b to the z sub 2. And next is we're going to write, since they have the same basis, so we can write this as difference of two exponents. So that is x over y equals b to the z1 minus z2. Then we can apply the definition of logarithm with respect to this exponential equation. So this is now log base b of x over y equals z1 minus z2. Okay, let's rewrite it here. Log base b of x over y. Now our z1 is equal to log base b of x. So log base b of x minus our z2 is equal to log base b of y. And that proves our equality here. Next, number three, let's prove the power rule. So let's begin by letting our z equals to log base b x to the n, which is our left hand side. Next, let's apply the definition of logarithm. So this is b to the z equals x to the n. Now what we're going to do next is let's multiply both sides by, or no, let's raise both sides by 1 over n, which is 1 over n, and this one will be equal to 1. So the exponent now of x is equal to 1. So we have b to the z over n, and the right hand side will become x. Next, let's apply the logarithm again. So this is log base b of x equals to z over n, and let's multiply both sides by n. So this will cancel out, and this gives us n log base b of x equals z. Now our z is equal to log base b of x to the n. So therefore, let's what's this? Flip this up. That's log base b of x to the n is equal to n log base b of x, and that proves our claim above. Number 4, let's prove the change base property or rule. So let's start from the right hand side, expressing it as z equals to log base a of x over log base a of b. Now let's cross multiply this and transfer the denominator to the left hand side. So we have z log base a of b equals log base a of x. And this one on the left hand side, we already proven the power rule, so we can apply it. Power rule number 3, we can apply it here. So we have log base a of b to the z, and this one log base a of x. Now since we have two logarithm on our left hand side, right hand side, so this implies that b to the z is equal to x. We can have a separate video for this, proving this two implies to this one. Okay, next is let's apply the definition again of logarithm with respect to this what's this exponential equation. So this is now log base b of x is equal to z, and let's rewrite this log base b of x. Now notice that our z from the beginning is equal to this, so that's log base a of x over log base a of b, and that is the same as our assumption here on top. So hence we have proven the equation or property. Now let's prove our claim in number 4 that if we have this log base b x equals to log base by, that means their arguments will be equal. Okay, so the proof is very easy, it's trivial. So let's begin from this. This means if and only if. So this one can goes implies to this one, and this side here implies to this side here. So let's begin from the left side of our equation. So that's log base b of x equals log base b of y. What we're going to do, let's transpose this to the left hand side. So we have log base b of x minus log base b of y, and that's equal to 0. Now this, we can use the quotient rule, so we can write this as log base b of x over y equals 0, and using the definition of logarithm, that's b to the 0 equals x over y, and b to the 0 is just 1, x over y, and then let's cross multiply this. Let's put our y to the left hand side, so we have y equals x, and that proves our property above.